This video is going to discuss Coulomb's law. By the end of this, you should be able to recite the properties of Coulomb's law and answer some questions related to it. So what is Coulomb's law? When a balloon is rubbed on a shirt, it becomes charged by friction, gaining electrons. It becomes negatively charged. If we take two balloons that are charged this way and bring them near each other, what would they do to each other? Would they repel? Would they attract? Would they do nothing? They would repel, and this is because since both of them have the same charge and like charges repel, that's why they would repel. They're going to move away from each other. But really, it's this like charge that forces them apart. I'm using the word forces there on purpose because Coulomb's law describes that force. It's called the electrostatic force, the force between charges. So the force between any two charges depends on two things: the amount of charge present on each object and the distance between the charges. The more charge that is present, the larger the force between them. And the larger the distance between the charges, the lower the force between them. They're further away, and if they're further away, then they're not going to interact as much. It results in a lower electrostatic force. The equation for Coulomb's law is this: electrostatic force equals 1 over 4 pi, this thing called epsilon naught, times the absolute value of Q1 times Q2 over R squared. That's a lot of stuff. But basically what this means is Q1 and Q2 stand for the charges. It takes two charges to do this. You can't have an electrostatic force with only one charge. And it's measured in coulombs, like all charges. R stands for the distance between the charges, measured in meters. Don't get it confused as radius. It stands for distance. Fe stands for the electrostatic force, and like all forces is measured in newtons. And then this thing right here, it stands for the vacuum permittivity. It's also called permittivity of free space, depending on the source of the information you're looking at. It has a value of 8.85 times 10 to the negative 12th Coulomb squared per Newton meter squared. So this is a whole bunch of constants right here, 4 times pi times epsilon. That combination of numbers and letters, 1 over 4 pi epsilon naught, is also called Coulomb's constant. So if you were to do 1 divided by 4 times pi times that value for epsilon at 8.85 times 10 to the negative 12, you would get this value, 9 times 10 to the 9. So depending on what is given in a problem, or for a variety of different sources and books or websites you look at, you might see it written with 1 over 4 pi times epsilon naught, or you might just see Coulomb's law written as Fe equals K Q1 Q2 over R squared, which is a smaller looking formula, but it's basically the same thing. Time for a challenge question. By what factor would the electrostatic force between any two charges change if the distance between those two was quadrupled? Like, were you going to wait for me to say it, or are you going to actually think about it? If you said 1 over 16, you'd be correct. Because since things that are further apart, charges that are further away from each other, would interact less. And the distance in Coulomb's law is squared in the denominator. So whatever factor happens to the distance, you have to square it. So 4 squared is 16, therefore 1/16 the force. This is much like Newton's law of gravitation, which was capital G times m1 times m2 divided by r squared. Same mathematical relationship, different letters, and representing much different things. Gravitation works for planets and solar systems, whereas Coulomb's law deals with the forces between charges at a very small scale. So similar mathematical ideas can help explain very different forces. Thanks for watching. Hope this was helpful.